big SQL queries can get messy very fast. In this tutorial, I will show you how we can use subqueries to break up big queries into smaller chunks that we can actually test, debug, and understand. We look at different ways how to use SQL queries, like in select, where, or even in joins. And we will also look at when you might want to use exist instead of in. Don't worry if you are not advanced. We will be going through it step by step, and I will explain it along the way. So let's jump right in, and we will start with a simple query that we will be optimizing using subqueries. All right, I am here connected to my AdventureWorks database, free database from Microsoft that you can download for free if you're interested to follow along on your machine. Anyway, let's select some data from this database. So we have list price, and then in here we have a table in the production scheme called product. And for now, let's start with an example which is not a subquery yet, but rather a hard-coded list of some product IDs that I searched for before. And if I run this, I get a list of 3 products. And this hard-coded list is something where we could also add now our subquery. So instead of hard-coding these values, I will go in here inside of these parentheses, and here I can add a subquery. I will indent it a little bit like this so it's easier to understand. But in here, a subquery is just add another query within this query. And here I can query anything I want, as always. And in this case, what I'm doing here is order quantity bigger 10. Here we have our first query, including a subquery. This is my inner query. If I execute this, I can run this part without the rest of the query, and here I get product IDs from the table sales order detail, which were ordered more than 10 times. These are the product IDs. I have them here. And this list, instead of with the in before where we saw we have 3 products, now we have here a list of, 2066 product IDs, which I can use in the outer part. So this here is the outer part. Here I can use it as my input for this where condition. Running this, I have now a list of 144 rows because there were some duplicates in here, and that's our first small little subquery. So outer query, inner query, all this together is our subquery that we were using. We can also use subqueries in our select list. So maybe we want to add another column here. And in this case, I have to open and close parentheses. And in here, I can write another subquery. Maybe I want to see the number of sales order detail. Now what we have here is a subquery in our select list, and this third column is the result. For all the rows, it shows the same value. So in the end, this value gets multiplied into all the rows that we have here before. Not very useful in this case, but possible. So you can add subqueries inside of your select list. Something I rarely do, but it's possible. We can also use subqueries to join to a subset of a table. Let me paste in a query here and run this one. Let's see what we have here. So we have an outer table, our employee table from the human resources schema, and then we inner join it to the result of a subquery. In this subquery, we query from our sales orders the salesperson, the order date, and the total due amount for the year 2014. And this result is treated then as a table for our join. And here we join from the employee table to the result of this subquery. And in the end, we are in the outer query, in the whole query, we are interested in the business entity ID and the job title from the employee, and the order date and the total due from our subquery, joined on the business entity ID equals to salesperson ID. This is in the end how the IDs are set up in this demo database. So this is a very powerful. So while possible, this is probably not complicated enough for me that in reality I would use a subquery. Let's see how we can write the same query without a subquery. So this one is equal without a subquery. We just move the where condition of 2014 to the where area of the whole query. But when we have a complex subquery condition, then it gets different. Unfortunately, I have to show you now a rather complex query. In this case, we want from our sales orders only the ones in 2014, but also grouped by the salesperson, the ones who have more than 20 orders. Let's run this. And then we see our salespersons and the number of orders that they were responsible for, or some orders were not managed by a salesperson. And then this result we take again to join it to an employee table. And here for the first time we can really see where the subquery shines. This is a rather complex logic that we have here, and we have it nicely separated from the rest of the query. If I would go ahead and rewrite this logic without a subquery, this looks complicated. While shorter, yes, we have less rows, but now we have mixed the join of the employee to the sales order with this grouping logic, where now we also need to group by the parts from the employee table, because this is how grouping works if we want later to have a count here. If I execute this, we get the same result, but this one much more complicated to understand than this one, where we have this complex logic nicely separated from the rest of the query. And also, as you see, when I mark it here, I can run the individual parts and see the result. This is not possible here. When I look at this query, I need to first fully understand what's going on, and I cannot really divide and conquer the logic, seeing what happens here. This is the big benefit of our subqueries. Now let's talk about scalar and multiple row subqueries and what that is. Here I have a query. Let me structure it a little different so we can easier see what it is. We have our products. From them we have the name and the list price, and then overall the average list price over all products. This is a scalar subquery, as it returns only one value that can be then distributed over all the rows. In this case, just the 438, something. Another scalar subquery would be the following, where we use the result of the average, this one value, as a filter. Only give me the products that have a list price over this average. So only show me the expensive products. But if I do the following, this will not work anymore. If I, instead of the average, select the list price here, and I get a lot of list prices over all our products, different numbers. If I try to run this does not work. And I get an error here that this subquery returned more than one value. And this is not permitted if I say bigger than. Because also logical wise, now I compare one value for each row to 1000 values. This does not work. So sometimes we need to have a scalar value. What we could do here is use a top one to make sure we only get one result. But in this case, as we saw, it's the 0. So now we will see all the products having more than 0 list price. So to wrap it up, if a subquery is a scalar or a multi-value subquery, in the end, it's just about how many rows are returned. Is it 1 row or 0 rows? Or is it more than 1 row? If it's more than 1 row, it's a multi-row query which does not fit everywhere. Logical wise, makes also not sense. And you will be presented with an error message. Next up, I would like to show you what correlated and uncorrelated subqueries are. So here's an example that we saw before. This is an uncorrelated subquery. If I run this again, you see, okay, I get the name and the list price only where products have higher than the average list price. But these are not correlated. Here I will just receive one value. Now let's make this one correlated. So the correlation will be between the outer and the inner queries. Let me break it up here a little bit so we can easier see what's going on. And now we add a where condition. Where. And also I need to give them names now because otherwise I cannot reference them correctly. Let's say we call this PO for product, no, PI for product inner. And this one will be PO for product outer. And from the product inner, we want the subquery category to be equal to the outer subquery category. Now those are correlated. As you see, we have the inner one and the outer one. If I try to run this one now alone, this will not work anymore because the outer one cannot be referenced if I don't use it. If I run this, we will see a different result. Let me run both at the same time again. In the top one, we have 304 rows. In the bottom one, we have 116. So what this now does is, for all the products from the outer category, it looks if the list price is bigger than the average list price of the same subcategory. So you have toys and cars. In this case, the list price of a toys product needs to be bigger than, let's say, the average of toys might be 10. If the product is a car, where the list price might be an average 20,000, so the list price needs to be higher than 20,000. Another query that's commonly used is an exists query, which is typically also correlated. So let's filter using exists. So from the employee table, we say where exists, and now we have a subquery that is correlated, as you see here. The employee is correlated to the sales order header. And then I cannot run this alone. But in whole, this works. And what we see here is now we query our employees, which have a total due amount within an order over 150,000. All right, the last thing I would like to show you are CTEs, or common table expressions. Let's say we have a simple query like this. We have again the product name for products which were ordered more than 10 times. This inner query can now be transferred into a common table expression. Let me copy it over here again, and I will take this inner part and say with, now I need to give it a name. Let's say multiple ordered as, parentheses open and close, and in here I put this subquery. Again, it returns a list of product IDs, and this is now my multiple ordered table. Now we can just say where product ID in select product ID from multiple ordered. This does exactly the same. We have defined a name for our subquery and used it over here. For now, I'd say this one looks simpler than this one, but once the queries get more complicated, it's always a good idea to exclude complicated parts as their own CTE, also because it's easier than to see what's happening in a query. Let's see then one more complicated example. Let's say in our analysis we arrive at a query that has two nested levels. So first of all, we have an inner query, let's say. This is just returning us the average order quantity of our details as a whole number. So in this case it's 2. Then this result is taken into a second level of subquery where we want to see the product ID of these, and then the whole thing is used to get the product names of those products that were identified here, having been ordered at least 2 times, or in this case even more than 2 times. Now let's rewrite this as in CTE. Let's say we have our often ordered products as, and in parentheses we have now our subquery. And we could take only this part, or in this case I would probably go ahead and take this part, because this together are our often ordered products. I can run this CTE that is made up including a subquery, and then use the result select name from production.product. This is our P, where product ID is in, and then we have select product ID from often ordered product. And it should be production. And there we have it. In this case, when you have 3 levels of subquery, this is always very complicated. And with this CTE, you can make it clearer what's happening. Select name from production.product. This is our P, where product ID is in, and then we have select product ID from often ordered product. And it should be production. And there we have it. In this case, when you have 3 levels of subquery, this is always very complicated. And with this CTE, you can make it clearer what's happening. All right, and this wraps up the tutorial for the subqueries. I hope you could take